In this video, we'll solve a one-step linear inequality. Once we've solved it, we'll graph the solution set to this inequality on a number line. And then we'll write that solution set using interval and using set builder notation. So I mentioned that this is a one-step inequality. It's just a simple one. We have x minus 3 greater than or equal to 2. So what we want to do is get x all by itself, and we are able to add 3 to each side of this inequality, and this will give us an equivalent inequality. So it'll have all the same solutions as our original one. So we'll take this x minus 3, and we're going to add 3 to that left-hand side. So x minus 3 plus 3. Now we have greater than or equal to. And in order to make sure that we're writing an equivalent inequality here, we're going to add 3 to the right-hand side. Now, we knew that we needed to add 3 because we had x minus 3, so that x minus 3 plus 3 that we have is now just x, which is what we wanted. So we have x greater than or equal to 5, and we get 5 by adding 2 and 3. So now we're going to represent this inequality, the solution set to this inequality, a number of ways. The first thing I'm going to do is just jot down that streamlined inequality, which is x greater than or equal to 5. Now I've got a number line here and I'll graph it. The first thing I'm going to do is make sure that I label this number line with x, since that's my variable. And then I'll mark off numbers on here. So I'm going to put 0 in the middle. And now I need to go up to 5. I can scale this a number of ways. Because I need to go up to 5, I'm going to make each tick mark worth 1 unit. And I'm only going to mark off 2's so that my numbers don't get too crowded. So I'll mark off 2 at the second tick mark, 4 at the fourth tick mark from 0, and then 6 at that sixth tick mark. To the left of 0, I'll do the same thing. 2 tick marks to the left, I'm going to mark off a negative 2. 2 more tick marks, I'll put negative 4, and then 2 more, I'll put negative 6. Now I'm ready to graph this, so I'm going to identify where 5 is, and that's between 4 and 6, so I'll mark it right here. It's greater than or equal to, so I'm going to use a square bracket and go to the right for that or equal to. Greater than part, greater than or equal to. The or equal to is what makes me use the square bracket. The greater than part is what makes me choose to go to the right. Now that I have that graphed, I can pretty readily write interval notation. I'm going to use that same square bracket and then a 5. And then next to that, I'm going to put the infinity symbol and an open bracket. And that just shows that it goes on forever in the right direction. Lastly, I'll use set builder notation. This is a way of demonstrating the set. There's not a whole lot to do with this. It's going to be the set of all x such that, and now I just include that inequality. So the set of all x such that x is greater than or equal to 5. And that such that bar is that straight bar that I put between those two x's.